Hey, you guys, it's Mrs. Horner here. Hopefully, you printed out the biogeochemical worksheet that you see before you. You're going to see my hand here, like writing in. Okay. And these are my drawings that I actually drew on the board one year, and I took a picture of them. And it's going to summarize all those biogeochemical cycles that we did, but with Mrs. Horner style pictures. Hopefully, you like my pictures. And I'm going to start with the water cycle. And what I want to do is I want to go through number one, number two, number three, four, five, six, and seven. There are seven processes here that I want to go through, and we're going to talk about which ones are biological and which ones are geological. Biological means that it involves a living thing, and since we're in biology, we care more about those processes sometimes than the geological ones. But the geological ones, we call them physical processes. Sometimes, like, your book breaks it down into like actual geological things, man-made things, or even physical things. But I just lump them all together and say they're physical. In other words, they're done by something that is not living. Okay, so let's start off. So number one, you see here this arrow that's going from the tree up to the clouds. And I always like to call it like tree sweat, but it's called transpiration. And I always say a good way of remembering that is remember that people perspire, but trees transpire. So that's transpiration. People perspire, trees transpire. And that's obviously, and I'm going to circle the things that are biological. So I'm going to write there's biological processes. I know you can't see with my hand in the way right now. Let me try to swing it around another way. Biological processes, and then there's physical processes. Physical. Scooch this over. Processes. And we're going to circle the biological ones. Okay, so whenever we go through these, we're going to circle the biological ones. And transpiration, because it involves a tree, which is a living thing, that's biological. Okay, number two up in the cloud here, it looks like the cloud is forming. Well, clouds form when gaseous water like steam starts to condense to form a liquid. So that is condensation. Condensation. And if you think of condensation like on your mirror, it's kind of like a little cloud on your mirror, like when you take a really hot shower. Number three is hard to see there, but number three is precipitation. Precipitation. Got a lot of that yesterday when it poured around here. Now my poor daughter up where she is, she's getting snow, precipitation in the form of snow. I think she said she's up to 4 inches already. Number four, here's where the water would be going into the ground. That's infiltration. I personally like the word infiltration better than percolation, but it could also be called percolation. Notice I didn't circle any of these numbers because there's no living things involved in this. 5 is runoff. And obviously runoff is like when the ground is so dry and it rains, and it just runs off into the streams and all, and that causes a lot of flooding and all. 6 is when the water goes from the liquid stage to the gaseous stage, and that's evaporation. Again, none of these are biological except for that first one. And finally, number 7 is absorption. Absorption is when the water is going from the ground into the roots. So it's a living thing involved, so we're going to circle that. It's definitely a biological one. So remember, biological processes and physical processes. The ones that are circled are the biological ones. Okay, on to the carbon cycle. Okay. And the reason we talk about biogeochemical cycles is we really want to know, like, how do we get these elements that we need for life? We say how like the fungi return nutrients, but where do all these like actual like elements come from? And what are the important elephants? I almost said elements. The important elements for life are C, H, O, N, and P. Carbon, hydrogen, oxygen, nitrogen, and phosphorus. Those are the biggies when it comes to like living things. And we want to know how we got that. Well, from the water cycle, because water is H2O, we have just realized how we got the hydrogen and the oxygen. We get it from the water. okay? Now onto the carbon cycle. Well, guess which element we're going to get here? Obviously, carbon. Carbon cycle, we're going to get carbon out of this. So now we'll account for the hydrogen and oxygen from the water cycle and the carbon from the carbon cycle. So let's look at these numbers and let's number them. And I believe we've got 6 to number here. 1, 2, 3, 4, 5, 6. Okay, and we're going to circle again. Ooh, let me scooch this up so you can see this. Okay, and we're going to circle the ones that are biological. So let's start with number 1. What's happening here? Well, this is my lovely picture of, a factory, and it's burning some fossil fuels. So that's burning, or we can even call it combustion. I'm going to call it combustion. Okay, and combustion is not done by a living thing. I know you might be thinking, well, the people in there, well, they're not burning themselves. Okay, if they are, let's not just talk about that. Okay, but anyway, combustion is not a biological thing. Number 2, carbon dioxide is being taken in by the plants, and that's for the process of photosynthesis. Photosynthesis. So not only does a plant take in water up with the water cycle for photosynthesis, it also takes in carbon dioxide and, of course, the sun. That is definitely biological, so we'll circle that one. Number 3, both the plant and the cow, you like my picture of the cow there? They're both doing a process we call respiration. Respiration is where you give off carbon dioxide. It goes back into the atmosphere. But respiration's main purpose is to produce energy in the form of ATP. Later on, we'll know that that's called adenosine triphosphate. And you might think like your body runs on food. It doesn't. You put food in your body and it actually is converted to this ATP, and that's what your body runs on. It's like, imagine if like you stuck like a hoagie in your car's gas tank and it transferred it to gas and then your car ran. Okay, because we know our cars run on gasoline. We always think our bodies run on food, but we don't. We put the food in our body and it's transformed by this process of respiration into ATP. That's what our bodies run on. And because living things are doing that, both plants and animals both do that. Even plants don't eat, but they keep some of the nutrition that they're making from photosynthesis. So they keep some of the food to themselves, and then the rest the plants eat. And so number 4, that's ingestion, and it's showing the cow definitely like taking in the grass. That's definitely biological. That's how we have to get in our nutrition. Number 5, what's happening here? Well, if like I were to draw like little bacteria in the ground, and over time and time and time, we have decay and decomposition. I'm going to write it as decomposition. I could have actually put like poopies back there with the cow and drawn an arrow kind of coming from the cow poopies into the ground. But first decomposition, that's like what happens on the surface. But after years, and we're talking hundreds of thousands of years, that decomposition turns to like a decay type of thing. And that's how like our natural coal and oil and gasoline is like made. But that is definitely a biological process. And finally, number 6, when carbon dioxide goes into the water, like the ocean and streams and all, that's just dissolving. That's dissolving. Okay, and that's not biological. So you can see in the carbon cycle, 4 of these things are biological and 2 of these things are physical. Kind of the opposite from the water cycle. When we did the water cycle, only 2 processes were biological. All right, now, hopefully my thing didn't bleed through too much on the other side. Did a little bit, but let's do the nitrogen cycle now. So the nitrogen cycle, we have only a few things here, but I do have to add like a number or 2 to this. So you're going to have to help me out and add these numbers. But we'll start with number 1, number 2, number 3, number 4. But we are going to add a number 5 and a number 6, and I'll show you where they get added first. All right. Now, nitrogen's an interesting substance. And remember, if I flip this back over, we've already accounted for where we find the carbon. and the hydrogen and the oxygen. Well, now we're on to the nitrogen, because nitrogen cycle is going to provide us with how we get the nitrogen. Well, nitrogen exists as N2 in the atmosphere. N2, we actually breathe into our lungs, we breathe out, we breathe it in, breathe it out, breathe it in, breathe it out, and it does nothing for us. But yet we need nitrogen, especially for proteins, building our muscles, and we also need it for our DNA and RNA. And if we just breathe this in and breathe this out, we never get it. So how do we get that N? And we need it just as N, not N2. We need it just as N. So we have to go through this whole big cycle, and you'll see how we get it. So it first starts with this first process. That's kind of an interesting process. This first process is called nitrogen fixation. You can just call it fixation if you want. Okay, nitrogen fixation. We're going to circle this because this is definitely biological, but there is also this physical side to it, and I'll show you that in a second. Notice this number 1 is on this arrow here and this arrow here, okay? So what does this mean? It means that, and what is this picture over there? That's a cloud and a lightning strike. When lightning strikes, it actually splits that nitrogen in the atmosphere, and it does then kind of settle down and kind of dissolve into the ground. But you can't wait around for lightning strikes, and they don't happen that often, actually. So that's not a common way, but that is a physical way of this first process called nitrogen fixation. But you see, I circled it. So there's got to be a biological one. And here's what it is. Notice this arrow is coming down, and it's going through the roots of this plant, which I have these little nubbies on. Okay, those roots are called nodules. I'm going to label that nodules. And inside those nodules, there's bacteria. Bacteria in nodules. That bacteria, we call it nitrogen fixating bacteria because it takes free nitrogen, and they're under the ground. This is very weird. And this plant most likely is a legume. Maybe you've heard that word before. That's like beans. Bean plants like soybeans and stuff like that. And some of your grasses are also legumes. And this is why a farmer will every so often plant soybeans in a field or something, because like farmers want soil that's rich in nitrogen. And they could do a couple of different things. They could put fertilizer down, but that's going to be a lot of money. They could put cow manure down. We'll see what that process is called in a second. They could wait for a lightning strike. That's not going to happen. Or they could plant legumes every so often, or grasses, soybeans, that kind of stuff. When they plant like grasses or soybeans in a field, that one summer it might just be a soybean field, and they'll sell off the soybeans and stuff like that, so they'll make money. But those soybeans, the little nodules in the roots that have bacteria in them, are converting free nitrogen into these ammonia compounds and putting them into the soil and making that soil rich in nutrients. So we want to think about farmers, okay? So I definitely want you to like kind of write farmers down here. And, if anybody around here is like a farmer, you live on a farm, you kind of know this. There's like 3 ways you can get ammonia compounds into the ground. Ammonia compounds are good in the soil. They make, good, healthy plants, and we need it in the soil. But what are they going to do? They're going to wait for a lightning strike? No. So you can say lightning, and you can cross that one out. They're not going to wait for that. Next thing you're going to say, fertilizer. Well, they might put cow manure down, or they might buy expensive fertilizers and till them into the soil or something. But really, they don't do that. That is very unproductive. So they don't really do that. But what they do, and I know I said do, is they plant legumes. Plant legumes. Think about the benefits of this. When they plant the legumes take the nitrogen out of the air, or the bacteria in those nodules in the legumes, take the nitrogen out of the air and change to ammonia compounds. So they're benefiting that way. Then they can sell the bean plants and make money that way. So lightning strikes, it wouldn't cost them anything, but they'd have to have a lot of lightning strikes out in the field, and they're lucky if they get a half a dozen in one summer or something. Fertilizer, too expensive. But planting legumes actually gains them money. Okay. So when you go past a field that like one summer it had corn, but then the next summer it's growing something and you don't know what it is, it's probably soybeans. And that's probably the farmer saying, I'm going to sell these soybeans this year, but next year my corn crop is going to be really rich like that. And talk to anybody who's a farmer. They'll tell you plant legumes is the way. So that's that first process.